So now we're going to go into using the debugger in Chapter 7. Now the book uses a different program than we're going to be using, so consequently the debugging process we're going to use will be different. Okay, so let's go ahead and get started, and we'll diverge from the book as we need to. On two occasions, I've been asked, "Pray, Mr. Babbage, if you put into the machine wrong figures, will the right answers come out? I'm not able rightly to apprehend the kind of confusion of ideas that would provoke such a question." And this is written by Charles Babbage, 19th century English mathematician, philosopher, inventor, and mechanical engineer who originated the concept of a programmable computer. If you enter the wrong code, the computer will not give you the right program. A computer program will always do what you tell it to. But what you tell the program to do might not be the same as what you wanted the program to do. Okay, so a bug is another name for an error or a problem in a computer program. Bugs happen when the programmer has not carefully thought about what exactly the program is doing. There are three types of bugs that can happen with your program. Syntax errors are a type of bug that comes from typos in your program. When the Python interpreter sees a syntax error, it is because your code is not written in proper Python language. A Python program with even a single syntax error will not run. Runtime errors are bugs that happen when the program is running, that is, executing. The program will work up until it reaches the line of code with the error, and then the program terminates with an error message. This is called crashing. The Python interpreter will display something called a traceback and show the line where the problem happens. Semantic errors are the trickiest bugs to fix. This bug does not crash the program, and the program appears to work fine. However, it is not doing what the program intended for the program to do. For example, if the programmer wants the variable total to be the sum of the values in the variables a, b, and c, but writes the total equals a plus b times c, then the value in total will be wrong. This won't cause the program to crash immediately, but it may or may not cause some other code to crash later on because of the unexpected value in total. Finding bugs in our program can be hard, if you even notice them at all. When running a program, you may discover that sometimes functions are not called when they are supposed to be, or maybe they are called too many times. You may code the condition for a while loop wrong so that it loops the wrong number of times. A loop in your program that never exits is a kind of bug called an infinite loop. In order to stop this program, you can press Ctrl-C in the interactive shell. Our quick key will be different for that since we're using a different program. Any of these things could mistakenly happen if if you're not careful. It can be hard to figure out how your code could be producing a bug because all the lines of code get executed very quickly and the values in the various variables change so often. A debugger is a program that lets you stop your code one line at a time in the same order that Python executes them and shows what values are stored in all the variables. A debugger lets you look at how each line of code affects your program. This can be very helpful to figure out what exactly the program is doing. Okay, so we're going to be using our debugger in our program. Okay, so basically the text goes through stepping through programs, stepping into and out of. Okay, so we are going to go ahead and just show a little bit of debugging inside our application in PyScripter, and then we're going to come back to the text. So let's take dragon.py as an example. So you should go ahead and open up dragon.py right now that's been completed. So basically there are just a couple things that we need to do to learn to debug in our program. Alright, the first of all is, remember last time we talked about turning on line numbers? Line numbers are really great to have on. So that was under Tools, and options and editor options, and basically you just go down to gutter and you put show line numbers. Click OK. Your line numbers will be on. Now to set what's called a breakpoint, what you're going to do is you're just going to click inside the gutter here. The gutter is this area on the left. All right, remember we kind of close this off. Okay, so the gutter's on the left. So let's say that I want the program to stop when we're debugging right here at display intro. Okay. Instead of clicking run in our program, we start the debugger just by clicking this little debug icon. All right, it's got the run button in it, but it's got a little bug next to it. Okay. So we go ahead and click debug right now. This is what happens. Okay, so the program runs all the way down the page until it hits the breakpoint that I put next to display intro. All right. Now basically what we have here, we have in our Python interpreter, we just have that this kind of ran up till here. Let's go ahead and put another breakpoint right down below display intro. And let's click basically this debug run will make it run to the next breakpoint. So we click on the next breakpoint. So notice what happened was it went into the display intro function. It wrote all our text out into the Python interpreter, and now it stopped next to cave number equals choose cave. Okay. So let's take a look over at the different tabs on here. These tabs at the bottom of the screen are actually where you're going to be doing your debugging. So our Python interpreter, that's where everything gets put out to. Okay. But then in the variables, basically what we have here is we have two types of variables. When we're outside of a function, we have globals and locals are going to be the same. Okay. So let's look right here. You see play again is equal to yes because it's already been set. Okay, so we can find every single variable that we have at the time we're looking at it. All right. And then local is going to be the same for us right now. So let's take a look. Let's watch cave number. Okay. So let's say I'm looking at my variable cave number right here, and notice that down in our variable list there is no cave number, right? Because the program hasn't gotten to cave number yet. All right. So in here, see there's no cave number here either. Okay. So let's go ahead and press debug again. So now this line of code is going to execute. So cave number equals choose cave. Okay, so the program runs. I put in cave 2 as my cave number and click OK. Now notice what happens is now in my variables, notice that cave number now appeared. Okay, so at this point when my program is running, there's a variable called cave number, and the value of cave number is 2. Okay. All right. Now we're at check cave. Okay, so we're going to go ahead and step into subroutine. Okay, notice that I click step into subroutine, right? Okay, so basically this takes me up to whatever the subroutine is. Now if I go ahead and click resume debugging, it's just going to run right through here, right? Okay, so I could also do step out of subroutine, so we can do step out of subroutine, right? And then I can click. Notice that in my Python interpreter, the very next thing here is he gives you his treasure, right? And now it's waiting. Okay. So now we stepped out of the subroutine. It ran the subroutine and then stepped out of it. Okay, and now we're going to click resume. Okay, and then it goes to the next line of code. It prints where it play again equals input. I'm going to put yes. Okay, but notice, let's go ahead and put yes, right? Okay, so I click OK. And remember, it does my loop. My breakpoints are still in place. All right. Now, interestingly enough, cave number is now still set because we're just looping. From the user's point of view, the game is still being played, right? So basically, they're playing a new game. From the program's point of view, that's looping. So now, remember, cave number is still set. Okay, let's take a look. Let's put some breakpoints into the actual functions. So let's put some breakpoints inside the function choose cave. Okay, so let's go ahead and put. If we want to step down through every single line, we can just put a lot of breakpoints inside there. All right, so I'm going to hit debug run. Okay, so it's going to go to resume. Okay, now I don't need to step. Remember, I put breakpoints inside of cave number. Okay, so I don't need to click step into this time. I can just click resume, and it's basically going to go. It's going to run up into choose cave and hit the next breakpoint. Okay, now let's take a look here under locals. Okay, so now I'm inside of a function. So remember, when I was outside of a function, my global variables were the same as my locals. But now that I'm inside of a function, the local variables change. Okay, so remember we talked about local and global variables in the last lesson? Okay, so now if I click my debug run again, okay, notice that now I created, on line 12, I created a variable called cave. Okay, so now we see cave appear. It's a blank string. All right. Okay, now let's say that I don't want to keep an eye on all the variables that I have in variables. I can actually create a watch. Okay, so let's create a watch called cave, and I did that already. Okay, so let's I'm going to clear all. I'm going to do add watch. I'm going to put cave. Okay, so it's going to find cave. It knows its variable right now is an empty string. So let's go ahead and press resume. Press resume. Okay, notice that the print which cave will you go into just executed. And now my next line when I hit resume is going to be cave equals input, right? So let's go back to my watch. Okay, so remember, watch is just a subset of all the variables, right? I can watch whatever I want to in there. It's a way to watch a bunch of different variables, just the ones you want to watch, right? Okay, so we hit resume using my input. I choose cave 2. Okay, so now in my watch, I see that cave is now the value of 2, right? Okay, now the interesting thing here is, watch what happens once we step outside of the function. So we're going to step outside of the function, right? Okay, so right now it went right back up to while cave does not equal 1 and cave does not equal 2. So basically it goes back up to the top of the while loop. It'll test if it's not 1 or not 2. Okay, it's false, and then it's going to go back down to line 17. Okay, there we go. It goes back down to line 17, which I have, it only stops there because I put the breakpoints. Okay, now finally, now watch what happens to this cave. Remember, we're going to return cave out of the function. So I hit resume, and now look what happened. I'm back out of the function, and the local variable now has disappeared. Okay, so the local variable was only existed while the function was being executed. Okay, so this is a really great way. These variables and watches are a great way, and breakpoints are a great way to just step right through and really look at what's going on inside your program. Okay, if we take all the breakpoints out, it's very hard to do that. All right. Okay, now there's a couple other things here. Basically, once you're done debugging, you can go ahead and stop debugging. Like when you click abort debugging, that will turn the run back on. The other thing you can do is you can toggle all of the breakpoints. You can clear all the breakpoints, but you can also toggle on and off all the breakpoints, and that's a quick key. Let's go ahead. If we want to just clear all the breakpoints, we can do that. So if we just clear them all, they're all gone. We can also abort debugging. So we want to get back to just running it normally. If we want to leave the breakpoints in but just run it normally, we can also just abort debugging and then click run. Okay, so let's get back to the text. All right, so what we have here, let's get back to find a bug. So we have buggy.py. So we're going to go new file, and we're going to open a Python script, right? We're going to Control A to select all. We're going to delete all the text that's there. Okay, so using the bug debugger is a good way to find out what is causing bugs in your program. As an example, here's a small program that has a bug in it. The program comes up with a random addition problem for the user to solve. In the interactive shell, click on the file, the new window, and open a new file in the editor window. Type this program into the window and save the program as buggy.py. Okay, so I'm going to go ahead and save it right now. So we're going to call it buggy.py. Don't have to put the py on in our case. Okay, so we're going to import random number 1 equals random dot rand int, okay, between 1 and 10. Number 2 equals rand dot rand int, also between 1 and 10. Okay, now we want to make sure that we type it in exactly as they have it here, because there is a bug in here somewhere, so you don't want to accidentally fix the bug before we're supposed to. So we're going to print what is, there we go, plus string number 1 plus, and then we're going to actually put a plus sign as a string, right? Plus, okay, and then we're going to go string number 2. Okay, so we're turning the integer number 2 into a string. And then we're going to add a plus. And then we're going to add a question mark. Okay, so the next line is going to be answer, input. Okay, and then we're going to go if answer equals number 1 plus number 2 . Okay, print correct. Whoops, print correct. Else print nope. The answer is plus string number 1 plus number 2. Okay, type the program in exactly as above, which we've done. Okay, and control save. So we're going to save it. Okay, if you can already tell what the bug is, even if you can already tell what the bug is, try running the program by pressing F5. This is a simple arithmetic game that comes up with 2 random numbers and asks you to add them. Here's what it might look like when you run the program. Okay, so we're going to go ahead and run the program. Okay, notice when you collapse the window, you might see the bug run again. Okay, but just go ahead, this kind of Windows style, more buttons, you're going to find just the plain run. Okay, so we run it. And what is 9 plus 5? And 9 plus 5, I'm going to say is 14. It says, nope, the answer is 14, but hey, that's the number I put in. Okay, so something is obviously wrong, right? Forgot to put in spaces too. Okay, so something's obviously wrong. That's the number I put in, and yet when I give it, it doesn't work, right? Okay, so we want to go ahead and debug this program, right? Okay, so we're going to go ahead and we're going to put in some breakpoints, all right? Whoops. I accidentally stepped into import random there. Okay, so we can use just the step, right? Step over. Okay, and we can see what the variables are, right? So we have number 1 Okay, and notice the types here, right? Okay, so we have number 1 and number 2 are 3 and 2. At this point, they've been selected. Okay, so we do step over. Okay, so now we're going to do answer equals input. Okay, and my number is, let's say the number is 5. Okay. All right, now we're going to go if answer, right? Say we're going to go ahead and step. Okay, so there we go. So obviously we got to this point and it tested as false, right? So now we need to figure out why it tested as false. It tested as false, right? Okay, so we can see here that the types of number 1 and number 2 are both int for integer, and the answer is a type of string. So remember that a string is always going to test as false. Okay, so we've found our error, and so we can see in our variables window that answer is a string, number 1 and number 2 is an integer. So of course those are never going to be equal to, they're never going to result in a true Boolean value right there. Okay, so all we need to do is just go ahead and convert that answer to a string by using the str function. Okay, and let's go ahead and see if our program runs correctly this time. Okay, we're going to abort debugging. We're just going to run. What is 3 plus 5? It's 8. Correct. Okay, so our program ends up running. So let's go ahead and save this off as buggy.py. Okay, and remember that this is the file that you're going to need to upload into the into your assignment. Okay, so let's go ahead and we're going to go ahead and read the section in breakpoints, even though we've already talked a little bit about them. So let's go new file. Okay, stepping through code one line at a time, which of course in our program was used with step into and step over. Okay, so the step commands. Basically you want to use step over most of the time unless you want to actually go into a function. Stepping through code one line at a time might be too slow. Often you will want the program to run at normal speed until it reaches a certain line. You can do this with breakpoints. A breakpoint is set on a line when you want the debugger to take control once execution reaches that line. So if you think there's a problem in your code on, say, line 17, just set a breakpoint on line 17. And when execution reaches that line, the debugger will stop executing. It will stop execution. Then you can step through a few lines to see what is happening. Then you can click Go to let the program execute until it reaches the end, or another breakpoint. To set a breakpoint, okay, so in our case we're going to go ahead and use, we talked about this before, we set breakpoints. For example, in Buggy, if we want to set a breakpoint, we just click here in the gutter and it sets a breakpoint. Okay, so let's go ahead and try it. Just try that quickly. So we hit debug. Okay, it hits our breakpoint, no problem. And then we can go ahead and we can go step, and it goes to, oh, nope. Okay, so we step one line at a time there. All right. Okay, so we can also say clear the breakpoints by clicking them again. We can run it again in debug mode. Okay, it hits our breakpoint. We can go ahead and start to step. Okay. Alright, so example of using breakpoints. Let's try debugging a program with breakpoints. Here is a program that simulates coin flips by calling random.randint01. Each time this function call returns the integer 1, we will consider that heads and increment a variable heads. We'll also increment a variable called flips to keep track of how many times we do this coin flip. The program will do coin flips 1,000 times. This would take a person over an hour to do, but the computer can do it in about 1 second. Type in the following code onto the file editor and save it as coinflips.py. You can also download the code. In our case, we're going to type it in though, because we don't download anything. for the purpose of learning how to program. Okay, import. Okay, so I'm just going to go ahead and type in the code here. Okay, so we're typing in it will come up heads, and then press enter to begin. Okay, and the line got a little long. Usually we go on to the next line, but that's okay. Okay, so let's make sure to all get there. Press enter again. Okay. So basically we're going to come up with a blank input, which by the way is a little bit weird to do, but I guess since we're beginning we can do it. So input, which is basically going to pause the program until the person hits enter. We're going to set the flips value as 0. We're going to set the heads value as 0. And then we're going to do while flips is less than 1,000. Okay, so if random.rand int is 0 between 0 1. If random.randint equals 1, okay, so we're going to choose a random value between 0 and 1. If it equals 1, we're going to say heads equals heads plus 1. That means to increment the value, so heads basically becomes whatever it was plus 1. Okay, then we're also going to increment the flips. So we're going to say flips. Now this is outside the if block, right? So we're going to increment the flips with flips equals flips plus 1. Okay. And we're still in the while loop. So we're going to go if flips equals 900. We're going to print 900 flips, and there are, we're going to plus string of heads, and we're going to plus, so we're going to say there are this many heads, right? Okay. Then we're going to say if flips equals 1,000, equals 100, we're going to print at 100 tosses, heads has come up. Okay, so many times so far. Okay. Now we're going to say if flips equals 500, we're going to print halfway done and heads has come up. Okay, so once again we use the heads value that's we're converting to a string. We're going to say times, right? Come up so many times. Okay, so there we have it. Okay, and then we're going to say string, and we're going to go print. So we're going to print a blank line, and then we're going to print out. So we got out of our while block, right? So while flips is less than 1,000. So once it goes 1,000 times, it's going to go ahead and exit. It's going to print a blank line, and then it's going to go out of. It's going to print out of 1,000 times coin tosses. Heads came up. So many times. Okay, so we're going to say, were you close? Alright, so we're asking, were you close? Okay, so I just noticed that I did an incorrect print there. I added a T. Okay, so we've written our program. Alright, it's pretty simple. So let's go ahead and we'll just run it one time to make sure we don't have any syntax errors. So I click abort debugging. Then I'm going to click run. Take out our breakpoints. Oops. When I forgot to save it, so we're going to file save as. And we were saving it as, what was that? We're saving it as coinflips.py. Okay, and notice they used capital F, so which is optional. Okay, so we're gonna run it. Okay, I will flip a coin 1,000 times. Guess how many times come up heads? I'm gonna say 500 times. Okay. Ooh, look at that. Okay, the wrong. I used a period, not a comma. So let's run it again. Guessing 500 again. I click OK. Okay, and it gives me all these things. It went very, very, very quickly, right? Out of 100 tosses, it came up 47 times. My spacing is off. Out halfway done, the heads came up 256 times. In 900 flips, there were 454 times. And then out of 1,000 coin tosses, coin tosses, heads came up 509 times. Okay, so my program is running correctly, so let's get back to the book. The program runs pretty fast. It probably spent more time waiting for the user to press the enter key than it did doing the coin flips. Let's say we wanted to see it do coin flips one by one. On the Unity shell, click on Debug. Okay, the program starts in the debugger on line 1. Press step 3 times in the debug control window to execute the first 3 lines. You'll notice the buttons become disabled because the input function has been called, and the interactive shell is waiting for the player to type something. Okay, so let's do that. We're going to do the step into. Okay, so we step into 1, 2, oops. We're stepping into the import routine, so let's go back. Okay, we're going to abort debugging right now. Notice that I put step into and not step over, so we actually want to put okay, so we want to step into, and on this one for import we want to step over. So we want to step over. Okay, we're going to step over. Okay, so now input happens. All the inputs become disabled, or the steps become disabled. I'm going to guess 507 this time. I click OK. Notice it just steps the next flips. Okay, so I keep clicking step over, step over, step over. Okay, so notice it just goes to the ifs and just keeps randomly. Notice if I wanted to get to the print functions, I would have to do this 100 times, right? So it's a long time. Okay, you can click a few more times, but you will find it would take quite a long time to get through the entire program. Instead, set breakpoints at 12, 14, and 16. So let's go ahead and do that. Set breakpoints 12, 14, and 16. Okay, now we can go ahead and click resume. Oops. Okay, and notice that the program runs super fast. You know, in the snap of a finger, it runs fast. So at 100 flips, it goes ahead and hits my breakpoint. So basically, flips equal to 100. It got to print, and now we can go in and inspect the variables that are there. Okay, so we can see that flips equals 100, heads equals 52. We can go ahead and actually look at what's going on in the program at a particular time. Okay, we can notice that it hasn't actually executed the print statement, but we can go in and look at the variables for heads and flips. Okay, great. So that so let's finish up here. After setting the breakpoints, click go in the debug window. The program will run at its normal speed until it reaches flip 100. So we don't hit click go, we just click the run button with the bug on it. On that flip, the condition for the if statement on line 13 is true. This causes line 14 to execute, which tells the debugger to stop the program and take over. Look at the debug control window in the global section to see what value of flips and heads are. Okay, so we looked at on our interface, we looked at the variables section, the variables tab, and then we can look at the globals section. So we see flips and heads right here. And see how the values in flips and heads have changed. You can click go one more time to continue execution of the program to reach the next breakpoint. Okay, we continue to watch flips and heads. So at 500 flips, this time we have 247 heads. Okay, that is because they are called in the order that their if statement's condition becomes true. Usually the debugger can help make it clear why this is. Writing programs is only part of the work for making games. The next part is making sure the code we wrote actually works. Debuggers let us step through the code one line at a time while examining which lines execute, and in what order, and what values the variables contain. When this is too slow, we can set breakpoints and click go to let the program run normally until it reaches a breakpoint. Using a debugger is a great way to understand what exactly a program is doing. While this book provides explanations of all the games in it, the debugger can help you find out more on your own. Good luck. At the end of this, you should be able to upload coins flip and random.py.